The neutral wire is necessary to equalize voltage in three-phase power system. Current flowing by the neutral wire compensates differences between the currents in separate phases. Thanks to this, voltage in different phases is aligned. Considerable amount of power in three-phase power systems is consumed by three-phase loads, electric motors, ovens, and so on. Each of the three-phase loads equally loads all three phases of the network. If single-phase loads consume the bigger part of power, such as in an office building, electricians try to distribute the load over the phases more or less evenly. For example, this is a typical waveform of currents in three-phase power network, loaded with lamps or motors. Currents in linear wires differ by no more than 25%. Therefore, current in neutral wire is small. It constitutes no more than 20% of the average current in linear wires. In consideration of this typical pattern, the neutral wire is normally made thinner than the other wires in three-phase power systems. For example, in a three-phase power cable designed for network, power about 70 kV-ampere linear wire has a cross-section of 35 square millimeters, and the neutral wire 16 square millimeters. This saves a lot of expensive copper and usually poses no danger, since the current flowing by the neutral wire is not high. The neutral wire is both working and protective PE conductor. Sometimes, instead of one neutral wire, two wires are fed, one of which is protective and painted green and yellow, and the other is working, its color is blue. Most often, transformer's neutral point, from which neutral wire is fed to all sections, is grounded. Thus, potential this neutral wire corresponds to ground's zero potential. Therefore, it is sometimes called the zero wire.